Hello, everyone. My name is Marco. I'm tech lead at Vulpem Ventures, and I do a lot of liquid development, especially. And in the last year, I've been focused in trying to create more developer tools and trying to help more developers to trying to build on liquid, and especially trying to create Bitcoin smart contracts, so-called Bitcoin covenants. So in this workshop, I will start just with some slides. So I will go through about the topic and trying to introduce a bit more. And also after that, I will start with some live coding. So I will show you some very basic example. Just let me check if all is good. I guess so. Audio is good. So, okay, we can start. So how Bitcoin smart contract development might look like in the future? I think Liquid is a nice testbed for this because Liquid is basically based on Bitcoin Core, and Bitcoin Script, which is basically the scripting language of Bitcoin, is the same as well for Elements, which is the name of the software, Elements Core, and there are some differences, and we will see these differences during this presentation. Currently in Bitcoin, Bitcoin smart contracts or Bitcoin scripts, you can enforce some sort of rules. These rules are, for example, who can spend, and this is the classic, I don't know, single sig wallet or just the normal wallet that most of Bitcoin wallets implements. Which basically constrained who is the owner of those Bitcoin, thanks to using just a public key. So whoever has the private key linked to that public key can sign and can spend those Bitcoin, effectively moving out from this contract or lock or script to somewhere else. Also, you can also encumber your script, deciding when you can spend. For example, you can say only the owner of this public key can spend this Bitcoin, and he can only spend after, for example, after 1 month or 1 hour, or after a specific block. Bitcoin with covenants, right, will allow you to add more rules. These rules are effectively how and where you can spend your Bitcoin. For example, I can say, hey, I want to spend just this amount of Bitcoin, only if they go to a specific address, and this specific address needs to maximum, for example, 0.1 or 0.05 to this other address. So we can create very expressive smart contract, just adding these very simple rules, how and where you can spend. I will not go over, all covenant proposals, as you imagine, it will take maybe 2 hours only to see all proposal altogether. I will just go very, very quickly. I think that currently there are two main category of covenants proposal. One is opcode based and one is signature based covenants. What we have actually in Liquid is what you see on the right, which is object sync from stack and cut. It's very simple. Actually, what object sync from stack opcode does is like, hey, give me any type of message, and whenever there is a message signed by this pub key, I will unlock your script, which is different than the current, check sig in Bitcoin, which actually requires to sign the whole transaction. With check sig from stack, you can, you can sign arbitrary piece of data. And the magic is when it's combined with opcat, which is a very simple opcode. And actually opcat was active in Bitcoin in the early days. And cat, the only thing that does is concatenating two strings together on the stack. Combining these two things, what you can do is basically you can try to create some sort of transaction template and use that transaction template and trying to introspect, the transaction in this way. You can create some sort of covenants. Beside these two opcodes, Liquid also has Elements script. In this case, is a superset of Bitcoin script, right? So as the same exact Bitcoin script semantic, the same exact Bitcoin script opcodes, plus more opcodes. In Elements SegWit v0, as I said before, we only have these 4 opcodes, which is checks inflow stack, cat, and substring and deterministic random, which is very interesting, which allow you to do some sort of lotteries or any other type of kind of gaming or gambling application. With TypeScript, with Taproot in last year, we had more opcodes, which didn't change regarding introspection, didn't change the functionality. You can do covenants already with checks inflow stack and cat, but with a specific introspection of code like inspect input, inspect output, you can do much more. You can develop much more easier. Just using these opcodes to be more granular, to introspect specific part of the transaction, and this way you can create covenants. You also have 64-bit arithmetic opcodes, and this was used by, for example, a project called Bitmatrix, and you also have SHA-256 streaming opcodes, so you can do much more things. What you can do, right, with Elements script? Well, a lot of things. Just with covenants, you can do a lot of things. One of these things can be vaults, and vaults or smart vaults can be recursive, non recursive, and these allow you basically to even lose all your keys, right? And basically, you can always claw back your funds. So this is definitely improve Bitcoin custody in general. You can also do AMM pools, and this is maybe from Ethereum world. You can really rebuild Ethereum, and this is not just a theoretical concept, but Bitmatrix, built by Burak, which who had a workshop last week as well. It's called Bitmatrix. It's live, and you can already try that using covenants. You can also create lending pools or limit order, kind of order book on chain. You can also create option, and Blockstream has a research paper on that. And you can even, create crowd sale, crowdfunding contract, lotteries, roulette, and so on. These are just my ideas, but I'm pretty sure that, creative developer can think of more use cases as well. There are some developer tools out there that are very helpful, are not mandatory, but definitely I suggest to look it up. One is Nigiri, which is basically a Docker box, which with just one click will spin up for you a Bitcoin node, a Liquid node, an Explorer, both backend and frontend, and also some machinery to automatically mine for you block when you broadcast a transaction. And also you have a CLI, which allows you to do to faucet, to your wallet. So in general, developer tooling that will be helpful for developer. Another interesting tool is Script Wizard. Last week there was a workshop by Burak on this, and Script Wizard is very helpful, especially when you write opcodes, because it lets you debug your element script opcode by opcode, and you can see the stack execution. I highly suggest to look it up. And Marina Wallet, which is a browser extension, and allow web developer to basically just focus on the transaction logic, and all the key management, all the key signature will be done by a browser extension in a isolated and sandboxed context. So we don't basically require people to paste their private key, which is highly insecure. So Marina Wallet definitely help developer to just focus on the logic and not on key management. The current ecosystem of Liquid and general smart contracts is like emergent, but is a lot of projects are coming up. As again I mentioned already, Bitmatrix, which is a on-chain AMM. There is also Fuji Money, which I'm involved with, which allow you to do trustless borrowing of synthetic stablecoin. And option, and in general option contract, which is a research paper by Blockstream, which is working on, I guess this presentation is a bit old. I did last 2 months ago. I think Blockstream released a client, a reference client, so I think it's not soon anymore. So is there, I'm not sure if it's mainnet live, there is any capital yet, but I'm pretty sure that all the tooling is there, so I highly suggest to look it up. Another interesting concept is the fact that actually, if you're building smart contracts, you don't need to have any liquid Bitcoin, which may add some friction to your user. But instead, if you are now, for example, building a Lightning application, right? Most of, I would say 99% of Lightning application for the nature of Lightning are centralized with a database. I think a lot of use case, you can swap your database, your centralized database for a liquid smart contract. And for the user standpoint, the user will never even see liquid at all, because liquid will only be used in, let's say, backend, which is the smart contract. And then you can fund, thanks to summary swap, which is offered by either Boltz Exchange or PairSwap. You can fund the smart contract, do your execution on liquid, and then you can exit again from liquid at the Lightning Fast, right? So I think this model will be very compelling for, increasing the user base for, liquid application in general. So, okay, let's get our hands dirty. I think that writing script is hard, and Burak in the last workshop showed us how to do it. But I would say that spending and debugging your script is 10x harder, even more harder. That's why, as Vulpem, we are focusing now on building Ionio. Ionio is basically two things. One is a compiler, which is not ready yet, is a high-level smart contract language, which compiles to Element script and simplicity as well in the future. So it will allow developer with not low-level knowledge, but more high-level language to to write your smart contracts and compile them and execute in the liquid environment. And in the future, if Bitcoin will have simplicity or any other covenants, Ionio will also be able to compile for Bitcoin. I suggest to look it up and try to see. After the presentation, I will do a little demo live about how to interact with the smart contract. So we will assume that the smart contract will be already done. So yeah, again, what's Ionio? Ionio is a high-level smart contract language. It compiles back and forth to Elements mini script. It targets Elements script and simplicity bytecode. Is integrated with Script Wizard, and there are various concepts. And the more interesting thing is a set of SDKs. So basically, just having what they're called Ionio artifact, you can basically auto-generate the code that understand what that covenant, that smart contract is doing, and it will generate for you the code that automatically will create the spending transaction for you. So usually when you learn a new programming language, what you do is usually is a calculator, right? And of course, it doesn't make a lot of sense to basically use a calculator to lock your Bitcoin, because you don't want random people to solve your function and then take your money. But just for the sake of this presentation, I think is cool to try to replicate how it will look like a calculator with Ionio. So let's start just with the raw opcodes, how you would write a simple calculator that basically say, hey, if you solve the simple addition, A plus B, I will unlock your funds, right? So on the left here, A and B is basically the witness data. What's witness data? Witness data, you can think of it as sort of function parameter. If when you have your any programming language as concept of function, and basically if you have some sort of code, you have some sort of parameter, right? So witness is basically what you need to pass as a parameter to solve this contract, right? And usually for the classic, pay to pub key hash in Bitcoin or on Liquid, what you pass usually is the signature, right? In this case, let's say the user need to solve the addition, so you need to pass as parameter A and B. And on the right, you have OPAD, right? This is the actual code. And the OPAD execution will basically take anything that he has on the left, so A and B, will make the addition with push on the stack, and then it will compare, thanks to op equal, it will compare to sum. Sum instead is something that you are called inside your smart contract, right? And this, if you want to make a comparison or something similar thing, can be the constructor input, right? In object-oriented programming languages, you have constructors, right? So you basically, it's like how you initialize your class, and sum can definitely be a constructor parameter. It's something that basically is hard-coded inside the script. So what is doing this again is taking the witness data A and B. It will sum it and it will compare to what the developer basically put inside, or coded inside, which is the sum. Very, very simple. Doesn't make sense again to make this kind of smart contract, but I think it show the concept. How it will look like with Ionio as a high-level smart contract language. As I said before, right, we have a contract, and then the developer is just deciding a name and is calling this smart contract calculator. This is just something on top of it. It doesn't go inside Bitcoin script, but it's just some metadata for the developer to remember and to categorize his own contract. And again, we pass in as a constructor. We pass sum. And we also have a type, which is a thing that Bitcoin script doesn't have, right? So instead, Ionio will be a typed language. So we will have specific types like number, bytes, pub key, signature, data signature, and things like this. Then this contract has a single function. This function maps one-on-one to TypeScript script at span, taproot leaf, and the developer just gave an arbitrary name for this function, and it's called sum must be 3, right? So it means that the function parameter, which is basically again witness data, needs to be 3. And the code is very simple. So we are creating a variable, we are doing a plus b, and then we use verify, which is it basically translates to op equal, and you will make sure that the result and sum are equal. If this is doesn't throw, if verify doesn't make any error, it will basically go through and will unlock the Bitcoin, right? Bitcoin or any other liquid asset if we are on Liquid to anywhere else. Writing this contract, it will basically compile this artifact. What's an artifact? An artifact is like if you have knowledge of, for example, Java, or is very similar to the ABI, the application binary interface. Or if you have knowledge of Solidity, for example, for the Ethereum virtual machine, it's very similar to the ABI JSON that basically Solidity compiles to. This JSON is not something that human should write by hand, although they could, but this is something the compiler will automatically generate. And this data, this JSON, is very useful because it can be given to any SDK or any library, and the library will just looking at this JSON can automatically generate the code to be able to spend and create the spending transaction. In this case, sum must be 3. And in general, you will also understand, if there is any covenants or if there is any time lock or any other things that, are not evident, are not self-evident, just looking at an address, for example. I think I will not go through all the details. There is a documentation for Ionio, so definitely there is room for more, but I guess this is the bare minimum to get started. Yeah, as I said, Ionio SDK is allow you to automatically generate the code to easily spend taproot outputs that are described by Ionio artifacts. How it will look like using the Ionio SDK? It's very, I would say, very, very simple compared to manually, create your transaction from scratch. So what we do is basically we are passing the artifact here, the JSON, to the contract class, and then we pass the constructor parameter, right? And in this case is 3, right? Because we want the sum to be 3. So these allow you, this first line allow you to create the address. That's it. So after you do this, you have the address with the script already compiled. Then let's say that someone fund or deposit some Bitcoin in this contract. And with contract.from, this is just basically the TypeScript, JavaScript SDK, right? So with contract.from, I can basically say, hey, there is a live instance of this contract in the blockchain, and I will tell you as a SDK where it is, right? So I need to give you the out point, which is transaction ID and the index, the out point, and also the prev-out, right? So I will give you the whole prev-out with the asset, the value, and the script. Once the instance is live, then we can assess sum must be 3 here, right? And this sum must be 3, what we is going to do is preparing the witness, compiling the transaction, basically. And if you remember, right, if you go back, the developer decided that the function should be called sum must be 3, right? And automatically, thanks to the artifact, this SDK understands and knows that there is a way to spend these funds locked in this special calculator, and that is called sum must be 3. And it also knows that there are two parameters, A and B, and these two parameters are numbers. So for example, if the developer here is passing, I don't know, some string, it will throw you an error. So you don't need to wait to broadcast the transaction. You will know beforehand that the types are not correct. And then, there are some convenience function like with recipient or with UTXO. So if you want to attach more stuff to the transaction, we can do it. In this case, I'm just adding the destination where we want to send the Bitcoin once are unlocked, right? And then we want to sign this transaction. Actually, it's not signing because there is no check sig operation, but unlock basically just finalize the transaction and make sure that we can extract to a raw transaction we can broadcast to the blockchain. So, okay, let's basically jump fine for theory. Let's get, our hands dirty and let's do it, let's see how we can do a web app that basically creates the calculator address and get funded and also create the spending transaction. So there is a blog post here, which we can check. All right. There is this Ionia calculator blog post that which goes step by step, and this is what we are going to do basically now. So the first step is like getting our developer environment. Of course, we are developing against reg test, and as I said before, I think it's very useful to have Nigiri in your local environment, so you can spin up a full blockchain, which is not just elements core running, but is also the Explorer front end, and also some more tooling like some, automatically broadcast and automatically mine a transaction when it's broadcasted. We also requires, to have Node.js, and optionally you can have Yarn because I use Yarn in this tutorial, but you can definitely use NPM as well. So let's say that the first step, installing Nigiri, is already been done on my machine. So the only thing I want to do is spin up a full developer environment. So I go here, I type Nigiri start -- liquid. What is happening here, as I said, you have Bitcoin here, you have Liquid, you have Elect, which is Electrum by Blockstream. For Bitcoin, you have also one for Liquid, and Chopstick, which is basically, our, I would say, JSON pass-through that allow you to do all the tooling on top of it, and Explorer, which is the front end. So if I go here and I go to localhost 5001, this is basically my reg test blockchain. My elements are reg test locally running, and there are 2 blocks being mined already, right? So, okay, we have done our first step. Let's go to setting our web app, right? I provided this Svelte. Svelte is a JavaScript framework. I provided this so you can easily have a web app already there. What this command is doing, is cloning this my template in a folder called Ionio app. Let me just check again on the screen sharing. Let me see if nobody's complaining, so okay, keep going. Since I don't have my highs on the chat. So the next step will be, okay, we enter the folder. Okay, we need a couple of dependencies. One is the Ionio SDK. So from npm you can install Ionio SDK that will be able, to, as I said before, to generate our spending transaction. And also we need to install SecP for the browser. So Bitcoin.js organization, we can use the SecP library from the Bitcoin.js. So in my folder, okay, so it will take a bit to install all the dependencies. All right, Ionio depends on Liquid.js, so which is the Bitcoin.js fork for Liquid. Okay, let's say that, our compiler, which yet does not exist, right? As I said, the Ionio is still being worked on, Ionio the compiler, but all this decay part is already done, is ready. So let's say that, we wrote this very simple, opcodes, which is opadd, the sum, and op equal. One thing I want to mention here, as you can see, this is not just script, but there are also template strings. This is important because, we can automatically replace this sum with basically these constructor inputs, which is typed. So we know it's a number, and also we also know all of those two are number. And this dollar and sum allows us to, automatically generate our code and fill the part of the code that will be supplied at runtime by the SDK, by the developer. So what I'm going to do is basically creating this JSON. I can put it anywhere else in my folder, right? So let's put it in the source. I'm calling calculator JSON. All right. Let me open this in my code editor. All right. Okay. I copied my calculator, my Ionio artifact here. I hope it's in the screen sharing is big enough to be seen. So let's try to just run the app like it is. This is just, a clean app. So what I can do is yarn dev, which will run our application. So let's go look it up here. Okay, very basic. Hello friend, right? There is nothing. It's very basic Svelte app. We added our JSON, right? And this is, again, should be the result of the compilation from, the Ionio compiler. What we need to do now is, just adding some layout and some state. It will not compile, but we just go step by step. So we see the code. So what I do is basically taking this code and putting in the, app.svelte in my editor. So I go here, and after the title, I put this box. Will be used later. So of course now is having some error here. So let's go forward, and then everything should sort out automatically. So we want to add some JavaScript, right? So we want to add some JavaScript, which will basically create the contract, show the address to the user, right? So the user can fund the address with some Bitcoin. And then we also want to spend from that address once it's funded. So I copy paste this, and then we go step by step, line by line, so we understand what is doing. All right. So basically this code, let me see if it's compiling now. Okay, let's go step by step. This is our contract address, right? This is an address which of course is not funded, because if I go check it out, there is zero liquid Bitcoin, zero asset, because we need to fund it. But let's see the code first. I'm doing some import of some stuff. Most notably, what I'm doing is importing the contract class from the Ionio SDK and the artifact just as a type. Also, I'm importing the artifact JSON that I copy-pasted before. The first thing we do is like, okay, we want to say this is the network, right? Which I'm importing from Liquid.js. So, okay, we want to work in the reg test, right? Then I have some state, which is basically what the UI is showing. And of course, now it's empty because it is not yet created. Then I have some variables. I want to fund this amount of sats, and this should be the fee, right? The transaction fee. But let's see how the Ionio SDK works. Ionio SDK is basically accepting at least 3 parameters. And the first parameter is an artifact, right? The first parameter of our contract should be the artifact, which is our JSON. And this will let the Ionio SDK to understand what our address is doing and how our address should be, what are the rules of our script and how we should generate the transaction. Of course, before generating the address, we need to supply our constructor parameter, which is basically, our coded parameter that needs to go inside the script. So it needs to be in the address before compiling. And in this case, it's 3, which is the sum of our calculator that needs to be complied to unlock our funds. Then I pass the network, right, which is a reg test. And also I pass, since it's modular, so I'm passing, the ACC, SecP library, which will be used by signing. Although this specific smart contract doesn't have any signature because it's just a simple, calculator. There is no checksig, but, we just pass it since it's used by, the Ionia SDK to, validate the public key and creating address and things like this. Then, okay, and basically, once we instantiate this contract, we can access many property, and one property is the address. So we know which address with this contract correspond to, and we can fund it. So this is the first step, and it's just, passing the constructor parameter, supplying our artifact, and only, getting the contract address. This contract address is binded, is connected to the UI, so is shown here. If you go back to our page, this address, right, is basically, our contract, right? And again, there is no balance, so we need to fund it. So let's go to the next step, funding our contract, right? So the next step is like I'm going to use the faucet, which is the command line of Nigiri, to fund our contract. And I want to send our 100K Satoshi of liquid Bitcoin to this address. So let me copy this command. And let's replace this. Oops. Let's replace this with our actual contract. All right. So okay. So we have our transaction ID. Let's go check on the blockchain. All right. So as you can see, Nigiri automatically did the mine. Otherwise, if you already know how reg test works, you should have done, like element CLI, generate to address, whatever. And Nigiri basically abstract this for you. So whenever you push or broadcast to the Explorer, we intercept that and we basically mine the block for you on your behalf. One thing we need to take notes now is the actual out point. The address, our address is this, right? Is being funded. As you can see, is a taproot address, right? Is a script span address. And we need to take notes. So this is the transaction ID, right? And this is the out one, which is basically the out point is like this transaction plus this index, right? So let's take note. I just want to copy paste I will copy paste the transaction ID later. So let's take some code more. So let's spend from this calculator now, right? So we need to add some logic. So we need to add a button, and this button will basically create for us the transaction. So let me copy paste, and then again, let's go step by step. So after this, I add this function on click. And also I want to add this button, right? In the HTML, right? In the UI. Okay. Let me see if our web app compiles still. Yes, compiles. And as you can see, now we have this button, right? And clicking on this button, okay, let's see the actual code step by step. So when a user click on the button, what we do is like, hey, please tell me, your out point, your transaction ID, your VOUT of the actual funded UTXO. Then we need to say, as I said before, hey, a live instance of this contract exists in the blockchain, and they want to let you know where it is, right? So I need to passing the out point and the full previous output. Liquid.js has this function which basically converts the strings like contract address or Satoshis or the liquid Bitcoin asset to the actual bytes that goes inside the the liquid transaction. So yeah, you can just use this elements value and asset hash from Liquid.js, which comes inside Ionia, right? So you don't need to install Liquid.js separately, but it's already there. So this code is basically saying, okay, I know that calculator, I know how it works because you supplied before the artifact, and also you supplied the constructor parameter. Now, let me know it exists. Let me know if there is a live instance of this contract somewhere in the blockchain. Then next thing we do is say, hey, give me the recipient. If we unlock, we are successfully unlocking our calculator, where do you want the Bitcoin to go, right? So we are asking the user to, give us an address. Then it comes the actual clue part, right? The interesting part. And basically, let's just put away this code, but just focus on this. Instance as functions, right? And so I can access all the possible functions the artifact JSON has. And in this case, sum must be 3 is automatically generated from the JSON that has been supplied before, right? And I'm passing some value that are, doing 3 as a sum. I could have done even the opposite, like 2 plus, 2, 1, doesn't care. We don't care about the order. Then what I do, I have some convenience method, like with recipient. So basically I say, okay, this recipient should then get, in this transaction, should get, hold the Bitcoin, so sats minus fee and this asset. And also we need to, in Liquid, we have an explicit fee output. So we also have with fee output convenience method, which basically will add for us the fee output. Then we have this magic method, which is always there in Ionio function. And this basically is preparing the witness and finalizing the transaction for us. All of this, what we do with another convenience function is like, okay, I want to get the actual transaction, right? The raw transactions I want to broadcast. So what this code is doing is literally giving some user-friendly way to understand what are the witness data, the types of this data. So it will, assert or in general alert me if I'm passing data that are not like the one specified by the artifact. And this way I can, broadcast my my transaction. Let me check if I did everything. Yes. So, okay, I added my button, I added my code. All right, so let's try. Okay, as I said before, we need to take notes of our transaction ID. We need to supply. So our transaction ID is this. I remember that is out1, so the index one. Okay, now he's asking me transaction hash. Okay, out1. Okay, and now he's asking me a recipient, right? So let me check from Nigiri here. So let's get just a random address from Nigiri, right? From the elements core. So you can access all the JSON RPC, all the elements and Bitcoin CLI commands with Nigiri RPC. Then since we are using liquid, -- liquid, then get new address, right? This is confidential, so we want to get the, just for keep it easy and don't get in the mix blinding, which, so I want to get the actual non-confidential address, which is this. This is a random address, could be anything. So let's go back here. Okay, I pasted my recipient, right? And what I've done, right, is, doing all the process for us and creating our raw transaction. So finger crossed, let's go see how we can broadcast the transaction and see if, our calculator protected our Satoshi. I think it's very not a great wallet. So let me go here, let me copy this raw transaction. Okay, we broadcast. So the transaction was valid because, again, we passed the right parameter, right? We passed 1 and 2, and 1 and 2 sum together goes to 3, which is what we were expecting before. Okay, again, as you can see, the transaction has been confirmed automatically by Nigiri. And as you can see, this is our original, UTXO being spent that was locked in our covenant. I mean, it's not literally a covenant, but our contract. And, has been sent to the address and minus the fee. So I think this is more or less all. And of course, I mean, this is very stupid, example. There are much more, advanced example for sure. If you go to GitHub, for example, in the examples folder, you can have, I don't know, we have a lot of other example. For example, you have a vault, you have a calculator, so you can do much more complex thing, especially covenants and things like this. I think as a first step, just to show how web developer can integrate contract, liquid contracts, and how they can easily spend without being an expert of how the covenant works, how the transaction scripting works, and things like this. I think that that's all, more or less. I don't know if anyone has any question in chat, or want to speak. I don't know if there is any feature for participant to speak or ask question. I think that's your time. That's your moment. All right. Yeah, it's definitely recorded, so you can definitely check it out later. And I also suggest you guys to check ionio-lang.org and check the blog post there, which is basically what I have just explaining now. There is a question about, can you abstract away the manually input TXT WAV? Yes, this is just my web app, I was lazy, right? So definitely you can add maybe Electrum, or you can add any other API. You can automatically go check an Explorer to check if the address is funded, and then you basically take the transaction ID and the WAV. So yes, definitely you can do that. Just for the sake of the demo, I didn't add any other pieces of Explorer or things like this. Yes, for sure. I think that going forward, we can definitely do much more advanced stuff, and looking forward also to have the compiler, the smart contract language, available. And I think that will help a lot of developer, to lower the barrier for, covenants and smart contract development on Liquid. All right, since we are done, again, if you have any question, I'm more than happy to answer over Telegram, Twitter. Please reach me out.